All right, chem students. So in this video, we're going to be learning about how to find the grams of a molecule being asked for when we have a certain amount of grams of another molecule. So pretty much you're learning to use limiting reactants and essentially almost like a recipe. If you don't have a certain amount of a certain ingredient, then that means you're going to have to reduce the entire recipe because your ratios need to stay the same. So in this example, here's my balanced equation. It is already balanced for you. So I've got 4 silver, 2 H2S, 1 oxide, and those are my reactants. My products are 1 Ag2S and 2 water molecules. Okay, so pay attention to your coefficients. The ratios are 4 to 2 to 1 to 1 to 2. That's very important. Now, here's the question. How many grams of Ag2S, so I'm going to underline it, could be produced from 1.7 grams of H2S if sufficient amounts of the other reactants are present? So pretty much meaning I only have 1.7 grams of this molecule. I've got plenty of these two, okay? So we don't need to worry about those. All I need to focus on is this reactant, and then how much can I produce when I only have this much. Okay, so first thing you're going to do, oops, I apologize. I have a copying error here. That should actually be 2. Okay, so the first thing that you are going to do is we're just going to do dimensional analysis. Really is the easiest way to go about it. So this is your given information, and remember, we need things to cancel in order to get to the final answer. So I've got 1.7 grams H2S, but I need to find the actual molecular mass. So hydrogen, we've got 2 of those, and each one is 1.008 grams. And sulfur, okay, hang on, let me look up sulfur real quick. Hopefully it's real quick. Okay, so sulfur is not coming up quick. Let me pull up the periodic table of elements. Hopefully in your head you've already found it or you already know it off the top of your head. Okay, 32.06. So we only have one of those, so 32.06. Okay, so hydrogen total we got 2.016 and sulfur is 32.06. Add those two together and you get 34.076 grams per mole of H2S. So in order to get that to cancel, I'm going to have to put it on the bottom so that my grams H2S can cancel out. So 34.076 grams per mole of H2S. H2S. I'm going to have to write small if I'm going to fit this whole dimensional analysis on here. Okay, my next step. This is important. This is where knowing your ratio is very important. Okay, because now I need to cancel out my mole of H2S. Where do I get that information from? It's in your balanced equation. You see your coefficient? That means how many moles you have. So I have 2 moles of H2S. So that is going to go on the bottom. What do I put on top? Your ratio of what information is being asked for. We're being asked how much of this Ag2S molecule can be produced. So that's going to go on top. 2 moles of Ag2S. Okay, we're not done because we're being asked for the mass that can be produced. So remember, your mass is grams per mole, and I've got mole Ag2S here. So we need to find the molecular mass of Ag2S. So we've got your silver. We have 2 of those. Okay, right now we're just working off of the subscript. We're not worrying about the coefficient. So silver, how much does silver weigh? See if you can beat me. Okay, let's go to periodic table. Silver is 107.9. 7.9. And sulfur, we already have that. 32.06. Okay, so the amount of silver we have is 215.8, and we have 32.06 sulfur. So the total of those, I don't have it lined up properly, I apologize, but here we go. Okay, so we got 247. Okay, so 247.86 grams. You know what? I am writing this the wrong way. That needs to go on top. 247.86 grams Ag2S all over a mole of Ag2S. Okay, so now you can see that cancels out. This cancels out. These cancel out. Okay, so our final unit will be grams of Ag2S. I apologize for the sloppy handwriting. Now go ahead and put this into your calculator. Remember, all of the numerator is multiplied. All of the denominator is divided by. So let's go ahead and do that. 1.7 times 2 times 247.86 equals, now divide it by 34.076 and divide it by 2. Okay, and then we want to stick with significant figures, which we have 3 here. So we will round 12.4. There's your answer. So when we are given only 1.70 grams of H2S, our reactant, we will only be able to produce 12.4 grams of Ag2S. Okay, I hope that helped.